So in this video in chapter 4 summary, so first we will discuss and the summary of chapter 4, what is all about in chapter 4. First, we have a type of connections. So type of connections, whether it's connecting to a local printer in the home or websites in another country. Before any network communication can occur, a physical connection to local network must be established. A physical connection can be wired connections using a cable or wireless connection using a radio wave. So types of connections. So we have a type of connection like uh, in the part of embedded wireless of antenna of parts of the connections and internet connections, of course, and the Ethernet switch. So we have next is we have a network interface card. So network interface card is uh, or NIC or connects to a device to a network's internet. NIC are used for wired connections. So NICs are used for wireless and for end users. So we have a physical layer. So physical layers or the OSI physical layers provide means to transport the bits that make up the data link layer frame across the network media. These layers accept a complete frame from data link layers and encoded its series of signals that are transmitted under the local media. The encoded bits that comprise a frame received by either end device or an intermediate device. So we have a types of physical layer media. First is like copper cables, we have fiber optic cables and wireless. So we have a source destination and we have a source and destination node. So and we'll discuss this copper. So copper cables is the signals are patterns of electrical pulses. Fiber optics cables, the signals are patterns of lights, and the wireless, the signals are patterns of the microwave transmissions. So we have a properties of UTP cabling. So the properties of UTP cabling is when used a network medium, an unshielded twist pair of UTP cabling consists of four pairs of colors copper wires that have been twisted together and then encased in flexible plastic shield. It is small, it is small size can be advantageous during the installations. So UTP cabling, UTP cabling does not use shieldings to counter the effect of EMI and RFI. Instead, cable designers are discovered they can limit negative effects of a crosstalk by first we have a cancellations. So cancellation is designer now pair wires in a circuit. When two wires are electrical circuit are placed close together, the magnetic fields are exact opposite of each others. Therefore, the two magnetic fields cancel each others and also cancel out and inside outsides. EMI and RFI signals. So, next is varying the number of twists per wire. So varying the number is to enhance the cancellations effects of pair circuit wires. Designers vary the number of twists of each wire pair in a cables. UTP cable must follow precise specifications governing how many twists or braids are permitted per meters. So 3.8 feet of cable. So we have proceed to the next UTCP cabling standard. So UTP cabling standards is conforms of standard establishment joined by TIA and EIA, especially commercial cabling standards for LAN installations, and in the standard most commonly used in a LAN cabling environment, some elements defined of first we have a cable types, cable lengths, connectors, cable terminations, and method of testing cable. So we have a category in the UTP cabling standard. So we have first a category 3 cable UTP. First, it we have a 3 cable. So it used for voice communication, most often used for phone lines. So we have the category 5 and 5E cable UTP used for data transmissions and supports 100 Mbps and can support 1000 Mbps but is not recommended. So it supports a 1000 Mbps. So the last we have a category 6 of cable UTP used for data transmissions and added separators is between pairs of wires allowing it to function at higher speed. Support 1000 Mbps and 10 Gbps through 10 Gbps is not recommended. So we have a fiber media cable design. So fiber media cable design is optical fiber is composed of two kinds of glass, core and cladding, and a protective cutter shield jacket. So although the optical fiber is very thin and susceptible to sharp bends, the properties of the cores and cladding made it very strong. Optical fiber is durable and deployed in a harsh environment condition in a network around the world. So fiber media cable design have first is jacket. So jacket typically PVC jacket that protects that fiber uh, against abrasions, moistures, and other contaminants. The outer jacket's composition can vary depending on the cable usage. So the next one is strengthening material. So surrounds the vapor prevents the fiber cable from being stretched when it's being pulled. The materials used is often the same materials used to produce a bulletproof vest. So the next is I have a buffer. So buffer is to help the shield core and cladding from a damage. So buffer. So the next one is have a cladding. So cladding is made from slightly different chemicals than those used to create the cores. It tends to act like a mirror by reflecting light back into the core of the fiber. This keeps lights in the cores as it travels down the fiber. So we have the main core, which is the core is actually the light transmissions, and the elements of the center is optical fiber. The core is typically slice of glass. So this is the some parts of cable fiber. So we have the types of wireless media. So we have a types of wireless media. First is the IEEE and telecommunication industry standards for wireless data communications. Cover both the data link and physical layers. So wireless technologies is such as cellular and satellites communication can also provide data network connectivity. And however, these wireless technologies are used for wireless media. So we have a wireless standards. So the wireless standards is used for uh, technology. Common refers as Wi-Fi. WLAN use contention-based protocols known as carrier sense, multiple access collisions, avoidance. So the wireless NIC must first listen before transmitting to determine if the radio channel is clear. If another wireless device is transmitting, then the NIC must wait until the channel is clear. So we have a different types of wireless standards. So first is Wi-Fi that we wireless to to surf or to communicate. So the second one is we have a Bluetooth, and the third one is WiMAX. So what is the purpose of Wi-Fi standard? Like I said, the Wi-Fi standard is is a technology commonly referred as Wi-Fi, as contention-based protocols known as carrier sense. So we have a Bluetooth. So standards Bluetooth is used for wireless personal area network. A standards common known as Bluetooth uses a device pairing process to communicate over a distance from 1 to 100 meters. So um, not of none of the people now is using Bluetooth. So it's we have, if you have a large files and when you're using the Bluetooth, it's very slow to pass the file. So the next is we have a WiMAX. So WiMAX is commonly known as Worldwide in Interoperability for Microwave Access, used to point to my multi-point topology to provide wireless broadcast access. So we have this in summary. So in chapter 4 is all about the network access, and the TCP network access layer is the equivalent of OSI data link layer. So the OSI physical layers provide the means to transport bits that make up the data link layer from across the network. The physical components are the electronic hardware, device media, and the other connectors that transmitted and carry the signal to represent the bits. However, components such as network adapters, NICS interface and connectors, cable materials, and cable design are specified standard associated with the physical layer. So wire communication consists of copper media fiber cable. We have UTP, STP, and optical fiber cable become very popular interconnecting infrastructure network device. So the number of wireless enabled devices continues to increase. For this reason, wireless has become a medium of choice for the network is quickly gaining the popularity in enterprise networks. Among the different implementations of the data link layer, there are different methods of controlling access to the media. So we have LAN and WAN, topologies of physical logicals, and all the data link layer protocols encapsulates the layer PDU within the data field of the frame. So this is all about in chapter 4 summary, and that's all. Thank you.